All right, getting into second half of the chapter, section 3.4, looking at logarithms, some rules that you guys learned in logs last year in Algebra 2, the product rule, quotient rule, power rule for these guys. So for the product rule, what you want to remember is when you have a log where two items are being multiplied together, you can separate that into two separate logs through addition. Right, so the R goes with one log, the S goes with the other. We're separating by addition. The base does not change. Very similar with the quotient rule, except that it's subtraction. So whenever you have the division of two items going on here, we can separate them into two separate logs through subtraction. And then the power rule is where you can take the exponent and move it to the front, and it becomes multiplication. So it becomes C times the log of whatever. Guys get on these, especially the first two, as these rules get applied, they work because you are taking one log and breaking it or separating it into two different logs. So keep that in mind, right? That's how the product rule and the quotient rule work. Sometimes that gets a little confused if you're doing the log of something times the log of another thing. That's not the product rule, right? It's got to be coming from one log separating into two separate logs. You can go the other direction with this. If I have two logs that are being added together, if they have the same base, then I'm allowed to combine them into a single log through multiplication. Right, same thing with this. I can turn this subtraction of two logs into the division of a single log. And he can obviously go back to becoming an exponent. So we can go either way on those. So we're going to get a little practice on doing those guys. So here was one that was done for us. So they took the log of 16 times x squared times y to the third, and we're just applying any of those rules that can apply. This one comes with two rules. Because we have multiplication going on, right? 16 times x squared times y to the third. So we can separate all three of those items with plus signs into separate logs. So that's what you're seeing in the first line. We're using that product rule. Then we can say, how about those exponents? So one thing they decided to do, and this isn't necessarily required, but something that we can do, is 16 can become 2 to the fourth. Now, as all three of those have exponents on them, I can move all those exponents to the front of their log, right? So it comes out looking something like this. So for the one that I wanted you guys to try, this one right here, I already created space for this on the next page. So we're going to flip over and look at the log of 25xy to the third. And we'll be coming back to these other guys in a second. So here's just one for practice, so you can always pause and try this ahead of me. So first things first, taking that 25 plus log x plus the log of y to the third. And as you get better and better at some of these and you get more comfortable with them, you can certainly start skipping some of these steps. You're going to recognize, hey, that power is going to go in front anyway, so you might even write it there in the first line that you do this. So just to model it after what they did on the previous example, could certainly see that as 5 to the second. So they would write it this way so that they can move that exponent to the front. So let me take the same steps that they did. Right, now I can say, okay, now let's, as my final move, let's take the exponents, move them to the front of their log. So we got 2 log 5 plus log x plus 3 log y. And that would be as far as we could take it. Again, don't forget the base doesn't change. This started as a base of 10, and I kept it as a base of 10 all the way through. So let me take you back to example 3. All right, so this is very similar. All the same rules are going to apply. It's just a more complicated situation. So one of the things we definitely want to do anytime you see a radical is we want to change that into a fraction exponent, right? Because we don't really have those rules with logs for radicals, but we do have them with exponents, so we want to see that radical as a 1/2 power instead. Now I could apply the rules that we were seeing, right? So a couple things that we got going on here. First of all, this radical is over x squared minus 3, and so it has to continue to be applied to all of x squared minus 3. That's why we have the parentheses there. As we have the division, we know these will be separated with a subtraction sign. We know that 1/2 power is going to go to the front of his log. So here's, if you put it all together, you got the 1/2 power in the front of his log minus the natural log of x, because that's what was on bottom. All right, so we're going to try 1, 2 like that, just so you can get some practice on these. So I got 14 and 16 already on the next page for you. So we're going to give these guys a try. So 14 already has the exponents there, so we're not going to deal with the radical issue until 16. So a couple things we can do on this. First of all is, because it's division, we can apply the quotient rule and subtract. We know I'm going to be moving the exponent to the front, so if you see that in advance, you could just do all this in one step. But just to be safe, I'll do it in 2, just so you can see everything that's going on. So I got the natural log of x minus 2 squared minus the natural log of x plus 1 squared. So I just applied the quotient rule to separate those guys into 2 logs with a subtraction sign. Now we can look at these and say, all right, let's move those exponents to the front of their log. The parentheses do matter. We need to see everything that is being applied to that natural log. So do not lose those parentheses, because it does change the meaning of what you have. So we need to show that all the x minus 2 is applied to that natural log, and all that x plus 1 belongs to the natural log. So that would be as far as that one goes. So let's do the same thing on this. Let's apply that 1/2 power to the whole thing. So I wrote this one, or I chose this one, similar to the one like the example that we saw, but I wanted you to see how this is different when the entire thing is under the square root, because there are potentially 2 different ways we can write this answer. So let's take a look at this. So first things first, I want to convert my square root to a 1/2 power. And I'm not going to factor that guy. That's not what we're looking to do right now. I'm just looking to apply my log properties. All right, so here's what's different about this one than the example that I just did a minute ago. This 1/2 belongs to the top and the bottom, right? Because of the way it was given to us, not just the top. So I got to make sure when I separate these that I understand that this 1/2 belongs to both logs. So 2 ways you could write this. I could either say, let's separate these into 2 logs. So I get the natural log of x squared plus 1 minus natural log x squared minus 1. And so this would be one way we could write that. And again, notice I'm applying the 1/2 to both because the entire thing was under the radical. So it belongs to both in this case. Of course, you could just put the 1/2 out front and put the entire thing in like a bracket to show that the 1/2 again belongs to both. So you could write it this way too. Either way is fine. It's not right or wrong, just 2 different ways of doing it. So it's almost like you're factoring out the 1/2. And it could be written this way as well. So either way would be totally fine. But that's really it as far as all we can do with these guys. So we split them up through subtraction, applying the quotient rule, and then we applied the power rule to deal with that 1/2. Right? And so we would take, again, either way you want to write that answer would be acceptable. All right, let me move on to example 4. So now we're going the other direction with these logs, and now we are taking multiple logs and condensing them back into a single log. So if I have the log of something minus the log of something else, again, I can now combine those back into a single log as long as they have the same base. And because they're both natural logs, I automatically have a log base E, so I know they have the same base. So here's kind of their process, and then we'll try it on our own. So a couple things that are going to take place here. First of all, the 3 out front is going to go back to becoming an exponent. So that was the first thing that they did, was apply the power rule in reverse. And so that put us here. Now I can take that subtraction and say, okay, let's take these 2 logs, bring them together under 1 log using the quotient rule so that it looks like this, right? And then from here, they were able to simplify. So they were able to simplify the x's and go one step further. So if you can simplify, always good. It's like reducing a fraction, right? So if you can simplify, always a good thing to do. So we're going to try 2 of these, and I got them set up on the next page for us. All right, so we're going to start with the 22 here. So I put these in a certain order of difficulty. So we're going to start with this one, which I thought was a little bit easier. And so first thing that they're going to do is they're going to say, well, let's take the numbers in front, bring them back to becoming exponents. So I'm looking at the natural log of x squared minus the natural log of xy squared. So bringing those 2's back to becoming exponents. Now we can turn these into a single log. So they're both natural logs. So let's say the natural log of x squared over xy squared, which I'm gonna give that 2 to the x and the y because we are going to be able to simplify this. So let me save us a step and apply that right off the bat. So it looks like this. And now we could simplify the x squareds. Those guys can reduce. So it just becomes 1 over y squared. So if we clean that up as far as it could go, it should look like this. Something to keep in mind as we get into bigger versions of this in the near future. When you go to condense between logs and put stuff on top and stuff on bottom, one thing to keep in mind is the way the product rule and the quotient rule work is basically anything that's positive ends up on top of your fraction. Anything that's negative ends up on bottom of the fraction. Because you could easily switch the order of this and say the negative natural log of this plus the natural log of x squared, right? The sign doesn't change, right? So whichever one had the negative in front of it should still go on bottom, and the one that had the positive in front of it would still go on top. So just pay attention to those signs, and then you're always kind of safe that way. So let's try one more like that. Notice on this one, this is already x to the 4th. So when I move this 2 to the exponent, think of your exponent rules for a power raised to a power, right? So if this is x to the 4th squared, right, we know the rule is to multiply those exponents. So as I bring those guys back together, I should be looking at x to the 8th. And then this one did not have an exponent, so we're going to leave it like that. And again, the parentheses do matter because it's quotient rule. Remember, the one that's positive goes on top. So I'm now condensing these into a single log. So I put the x to the 8th on top. I'm going to put the negative one on bottom, so x to the 3rd times y. And then anytime we can reduce, let's do that. I know that when I'm dividing, the rule is to subtract my exponents. So I'm looking at x to the 5th on top and y to the 1st on bottom. And that's as far as that one goes. Let me flip over for you. All right, change of base formula. Kind of a couple purposes for the change of base formula. One was a calculator issue that we were using, but there is other purposes to doing this because a lot of calculators now can do things beyond a log base of 10. And I'll show you that on mine here in a second. I think I showed that in a previous video anyway, but we'll take a look at that. But the general rule for change of base formula is if I have log base b of x, one of the things I'm allowed to do is separate this into 2 separate logs. We put the x on top, we put the b on bottom, so it becomes log x over log b. And when you do that, the new base can become whatever you want it to be. But the key is that they're equal. So whatever this is, this has to be the same thing. So if you want this to be log base 10 of x over log base 10 of b, we can do that. But it can change to whatever we want it to be at that point. They just have to be the same. So in a case like this, if I wanted to evaluate this using the change of base formula, we would simply say log 16 over log 3. And kind of the initial purpose of doing that was kind of a calculator thing. Most calculators only do a log base of 10. And so you were not able to put in a base of 3 into a calculator. And so the only way to do a problem like this in a calculator was to create this scenario. Now they both have a base of 10. And so now I can say log 16 over log 3, and I can get my answer that way. However, calculators often now, especially if you have one of the newer ones, they could actually do it from here without you having to change the base. So like on this one, it's under the math button. If I hit math and I get this menu towards the bottom, if I look at option A where it says log base, so choose that one. Notice this one lets me put whatever base I want. So I can give it the base of 3 of 16, and I could have gotten my answer this way as well. So they mean the same thing. If you don't have a calculator that has this feature, then you would just do it this way. There are other purposes to this change of base formula. So even if you have a calculator that can do this, you still want to understand this rule because we're going to be using that later. Okay, so that still matters. So again, if I did log base 10 over 6, or sorry, log base 6 of 10, if I just wanted to apply the change of base formula, it would become log 10 over log 6. So it looks like this. And remember, these then automatically have that base of 10. So if I wanted to just simplify, let's say we weren't using a calculator and I just said simplify as far as you could go, we learned early on that log base 10 of 10 is 1. And then this would just be over log 6. So even at this point, if I wanted to put this in my calculator, I could do it from here, I could do it from here, or I could do it from here. All three of those would give me the same answer. Let me go down to one last scenario. So log base 1/2 of 2. So again, I could write this as log 2 over log 1/2. So the setup would look like this. And this one's kind of an interesting one because we could actually take this all the way down without using a calculator at all. So just consider your properties for a minute. I can apply the quotient rule to this. So I'm looking at the log of 2 on top. So I'm going to take that bottom, split it up using our quotient rule. So log 1 minus log 2. So it looks like this. Now from here, what is the log of 1? Right, we've talked about this. The log of 1, it would be 0, because 10, it's like saying 10 to what power is 1? Well, 10 to the 0 power is 1. So I can take the bottom. So if that's 0, all I'm left with is the negative log 2. And now if I reduce, log 2 over log 2 is 1. All I'm left with is that negative. So we can take that all the way down to just being -1 just by using log properties. So definitely one of those benefits of the change of base process. However, if you consider back to here, we really could have done that way back here, right? Because as we've already talked about, we could say 1/2 to what power is 2, right? Remember, that's the whole way we interpret a log. And so looking at this, you might be able to say, well, if I raise this to the -1 power, I get 2. And so really we could get here much quicker if we consider those rules too. And that is it for section 4. So to be continued.